So definite integrals are area, and what we're going to look at today is definite integrals and fundamental theorem of calculus. Yesterday we took a look at Riemann sums, the left, the right, the middle, the trapezoids, and that's one way to estimate it. Now I wanted to give this picture as well. Sometimes, especially on non-calculator parts, they'll give pictures like this, and sometimes they may say they have however many line segments, and then they have a semicircle, so sometimes they'll say that. But what this means is you're finding the definite integral from -6 to 9 of, let's just say this graph is of f of x dx. All right, so if I want to find the area of this, basically think about areas in your shapes. Okay, the area, this is a triangle right here. So how do you find the area of that triangle? It's 1/2, the base of that triangle is 2, and the height is 3. However, there's one more thing I'm going to add to this. All right, if the shape is below the x-axis, it's going to be negative. All right, so this is below the x-axis, so that is negative. All right, as well. All right, but it's a semicircle. What's the area of a circle, first off? Pi r squared. In semicircle, we divide by 2. Now, some of you are going to say the radius is 4, but it's not. The radius is actually 2 here. So it's going to be pi 2 squared divided by 2. All right, so I got that semicircle. Now here, it just kind of depends on how you want to divide this up. You could see it as a trapezoid. If you drew it right here, it's a trapezoid, okay? And you could just have this one trapezoid, okay? Or some of you, most of you are probably going to break it down into, you've got a triangle right here, so it's plus 1/2. Height, the height is 3, the base is 2. Okay, this is a rectangle right here. So the area of a rectangle is base times height, 2 times 3. Okay, now this, and that ends right here. Okay, that's a trapezoid. So 1/2, the height is, we'll say the height is from here to here, 2. And my two bases are 3 and 1. Which when I add them together make 4. And then I have this rectangle right here. So that is just 1 times 3. And I would add all that together. However, you can realize these cancel with one another. All right, so this is 4 squared. This ends up being 2 pi once it's already, or -2 pi once it's reduced. Okay, this is 6. This is 4. This is 3. So that makes 13. So if I really just want to leave it as exact, I'm going to leave it like that. 13 minus 2 pi is the area underneath that curve. All right. Let me add one more thing to this. Sometimes what they can do is they would change, say if I said 0 to 9, I would only want this area right here, 0 to 9. Okay. So I would only do the x values that it actually shows. Also, if it showed absolute value right here, if it shows the absolute value, remember that means everything positive, it's like these two would flip up here. Instead of this being negative, those would be positive, and those wouldn't cancel out. Okay, so just kind of remember some of those things, and we'll continue to work on that as well. But today we want to focus on the fundamental theorem of calculus and how do we do integrals and do them by hand. Okay, now if you remember, this is our upper bound and this is our lower bound. Okay, and then this is our integrand, what we integrate. Okay, and this is basically the variable of integration. Okay, so the fundamental theorem of calculus says this. Well, think about it. When I integrate it, I'm going to call this big F, is the integral, or the antiderivative of it. What we do is we take, once you find the antiderivative, you're going to plug b and a in, and this is what we're going to do. We're going to do big F of b minus big F of a. That's the fundamental theorem of calculus. Okay, so watch how we do this right here. We're basically finding the area under the curve of x cubed, all right, from 2 to 3. All right, if they said from 3 to 2, we would put the 3 here and 2 here. Okay? So here, what we can do is we're going to integrate it. So x to the 4th over 4. And then I put a bar here and I'm saying 3 to 2. That means I'm going to plug 3 in, I'm going to plug 2 in. I put my upper bound in first, 3 to the 4th divided by 4, minus 2 to the 4th divided by 4. 3 to the 4th is 81. 2 to the 4th is 16. All right, when I do the 81 minus 16, I get 65. So this is 65 over 4. You can get a decimal of 16.25, but I would just leave it like that. All right, moving on. Okay, let's do this again. So what we do is we integrate. So this is going to be x cubed divided by 3 plus 2x. Because these are definite, I don't need plus c. And I'm doing it from 1 to 3. Okay, now in all of this, you have to plug in the 3. So I'm going to put a bracket, 3 cubed over 3 plus 2 times 3. Minus, okay, now you're plugging in the 1. Okay, 1 cubed over 3 plus 2 times 1. And then we reduce it. Well, here 2 cubed is 27. 27 divided by 3 is 9 plus 6. Now, we have to be careful here. Okay, we're cubing all of this, but it's minus. So it's minus 1 over 27 minus 2. All right, and then if you throw that in, you should end up getting 38 over 3. All right, on an AP test, if you wanted to leave it like this, you can leave it like that. They don't care for you to reduce it. Okay, unless it's multiple choice. And that could be something you do without a calculator. So be good with fractions without a calculator. All right, moving right along. We're going to do this one right here. So x cubed minus x squared. And I forgot to divide this by 3. I guess divided by 2. And I'm doing it from 1 to 5. So we put in our upper bound first. 5 cubed over 3 minus 5 squared over 3. All right. Minus, okay, now we're going to do 1 cubed over 3. All right, and I actually messed up here. I shouldn't have put parentheses around this. I'm only cubing the 1. I don't know why I did that. So this 3 stays underneath. Sorry about that. Okay, so the same thing is going to be here. The cube is only on the 1 here. So minus 1 squared over 2. Okay, so here we go. This is going to be 125 over 3 minus 25 over 3. Okay, this is going to make minus 1/3 and then plus 1/2. When I go throw it in my calculator, you should be getting 88 over 3. All right, here we go. Here's some trig ones. Well, here the antiderivative of sine x is negative cosine x. All right, and I'm doing it from 0 to pi over 2. Okay, so here I have a negative cosine of pi over 2 minus negative cosine of 0. Now that can go to a plus. Now, pi over 2, remember that cosine of pi over 2 is 0. So this is going to be 0 plus cosine of 0 is 1. So the area underneath that curve is 1. All right, and I didn't mean pi right here, I meant x. Sorry about that. Okay, that's the antiderivative. The antiderivative for secant squared x is tan x from 0 to pi over 4. So I'm going to do tan of pi over 4 minus the tan of 0. Well, tan of pi over 4 is 1, and the tan of 0 is 0. So So that also equals 1. Okay, now as far as some properties and special integrals, I have touched on some of these in previous lessons. Okay, so it may be a little redundant. If you ever have a constant out here, that constant can go out in front and just get multiplied by the whole thing. Now, if you're adding and I'll add in subtracting here, you can actually break this apart. Just make sure you put dx with each one of them and put a plus or minus in between whichever one you're doing, and actually do each integral separately. Now, anytime your upper and lower bounds are the same, that just equals 0. Okay, so quickly just know that property. It shows up every now and then. Now, one thing we can do with this is we can actually switch our bounds, and how we switch our bounds is we can put a negative out here. We're not going to do that much now, but it will apply later. So remember that right there. And then for piecewise functions, we can break it apart. And let's say C is in between A and B. I can say A to C of f of x dx. All right, plus from C to B of f of x dx. All right, and we're going to do one right now that is a piecewise, although at first it's not going to look like a piecewise. Okay, so let's think about absolute value. They're actually piecewise functions. We don't have a way to do absolute value. So what we do, and think about this for a second, it's a V shape. Okay, the should be here at 1.5. So it's doing something like this. All right, well, you have a line here and a line here. One of the lines is negative and one of them is positive. Okay, so this is thought about to be the absolute, or f of x would be negative 2x plus 3 and then 2x plus 3. But where does it stop? Well, it's where that vertex is, basically where this equals 0. So if I set this equal to 0, I get 3/2. Okay, now I need to know what to put. Well, here, I do it like this and like that. So it was negative from anywhere less than, okay, and notice I just plugged in the negative signs. And then it was positive, that line was positive anywhere it was greater than 3/2. Okay, and I can put equal to on both of these because either one are going to give us the same thing. All right, so here we go. So one of them's going to be, now notice my lower bound 0, so I'm going to start at 0 and then go to 3/2 of this negative 2x plus 3 dx. And then I'm going to go from 3/2 all the way to 3, where my upper bound ends at. But I'm doing this from 2x, and that should say minus 3. The actual thing inside, dx. Okay, so let's integrate it. This is going to be negative 2x squared over 2 plus 3x. And so here the 2's cancel, and I'm doing this from 0 to 3/2. All right, plus, all right, then I do it again, 2x squared over 2, and then minus 3x. And I'm doing that from 3/2 to 3. All right, I'm going to have to erase this one because I'm not going to have enough room. Okay, and again, these 2's cancel. So I'm going to plug in 3/2, so it's going to be negative on the outside, 3/2 squared, so I'm not squaring the negative, plus 3 times 3/2. Now, some of you may say, well, if I plug in 0, this gives me 0, so I'm not actually going to plug that in. All right, plus, okay, I am going to have to plug in the 3/2 here, so I am going to use brackets. So 3 squared minus 3 times 3, okay, minus, now we're going to plug in 3/2 squared, and it's positive this time, minus 3 times 3/2. And all of that's subtracted, so I put it in brackets. So this is negative 9/4 plus 9/2. Okay, plus 9 minus 9, those actually cancel. Now this is going to be a minus 9/4 and then plus 9/2. Okay, so this actually gives me negative 18/4 plus, that's 18/2. However, if I change this so it's negative 9/2, I end up with 9/2 as my answer. All right, so let me do this again, but let me add that other problem back in here. Okay, these take a little more work than apparently I thought when I first wrote out the problems. All right, so here, absolute value, what you're going to do is you're going to change them. Okay, the first one is like the negative side. So 0, 2, and we'll figure out that in just a second, but this is going to be negative x squared plus 4. Just change the signs. Okay, now as far as this bound, you need to set x squared minus 4 equal to 0. Okay, so x squared equals 4 and take the square root. That's plus or minus 2. But which one is in this? Positive 2. So I'm going to go to 2. Plus, now this is going to pick up where I left off, 2, and I'm going to go to 3, but I'm going to use it as is, x squared minus 4 without the absolute value. All right, so now I integrate. So this is negative x cubed over 3 plus 4x, and I'm doing it from 0 to 2. Plus, this is going to be x cubed over 3 again, minus 4x, and I'm doing it from 2 to 3. All right, so this is negative 2 cubed over 3 plus 4 times 2. And I would put that in brackets. Now, if I plug 0 in, it makes 0, so I'm not going to do that. Otherwise, I would. Okay, plus, now I got to plug it into 3. 3 cubed is 27 divided by 3. Minus 4 times 3 is 12. Minus, and now I have to plug in the 2. 2 cubed is 8 over 3. Minus 4 times 2 is 8. So let's clean this up. This is going to be negative 8/3 plus 8. Okay, plus 9 minus 12 minus 8/3. All right, and plus 8 again. Okay, go add that up together. I would try it without a calculator because you will have to do some things without a calculator as well. And you end up with 23/3. All right, so here we go. Here's some more. Okay, this one is going to be u squared over 2 minus, now think of this as u to the negative 2. Okay, so it's going to be negative, or hold on, u to the negative 1 over negative 1. So really that just changes, and I'm doing it from negative 2 to negative 1. Okay, so here we go. We're going to do negative 1 squared over 2 plus, all right, think of this just as 1 over negative 1. If you want to change that so it's 1 over u, you can. Now let's plug the negative 2 in, minus, all right, negative 2 squared over 2, okay, plus 1 over negative 2. Okay, so this makes 1/2 minus 1 minus, that's going to be 4 over 2, which is 2, and then that's going to be a plus 1/2. All right, 1/2 and 1/2 make 1, but then cancel with that 1, and so I'm left with negative 2. All right, now this looks a little complicated, but if you can simplify, 1 minus sine squared is cosine squared. And what's cosine squared over cosine squared? 1. So really this just equals theta from 0 to pi over 4. Well, here I plug in pi over 4 minus 0, and I get pi over 4. So that looks more complicated than it is. This one's actually easier than that one. Okay, and let's look at 2 more trig ones. All right, now for this one, we can break it apart if you want, or we can keep it together. We can say, to integrate it, it's 2x. Now, cosecant squared x. What's the antiderivative of that? Okay, negative cotangent. So what's going to happen is it's going to be turned to a plus, and I'm doing it from pi over 4 to pi over 2. This is where these trig, the exact values come into play. So here I'm doing it 2 times pi over 2, okay, plus cotangent of pi over 2, minus, okay, now we're going to plug in pi over 4, 2 times pi over 4, okay, and then plus cotangent of pi over 4. Okay, this, the 2's cancel, and I'm left with pi. Plus, now cotangent, think that's cosine of pi over 2 over sine of pi over 2. Well, that's 0 over 1, so this is just 0. All right, that makes minus pi over 2. Now you're distributing the negative, so this next thing is going to be negative. All right, and that should be cotangent, sorry. Okay, well, tangent of pi over 4 is 1, so cotangent is 1, but again, I'm distributing this negative, so it's minus 1. All right, if I'm doing this without a calculator, okay, I changed all of them so they have the common denominator. And let's see, I'm going to have pi minus 2 over 2. Okay, otherwise I can just kind of leave it something like that. All right, and let's do this last one. This is going to be 2t squared over 2 plus, okay, the antiderivative of that is sine of t. These 2's cancel, and I'm doing it from negative pi over 2 to pi over 2. All right, so I've got to plug in pi over 2 and squared plus sine of pi over 2. All right, minus, okay, negative pi over 2 squared plus sine of negative pi over 2. All right, this is pi squared over 4 plus sine of pi over 2 is 1. Okay, minus, okay, that's going to make pi squared over 4. Those actually cancel. All right, and this, the sine of negative pi over 2, that's where 3 pi over 2 is. So it's negative 1, but it's negative of negative 1, which makes positive 1. So the final answer is 2. Now, I do want to show you something, and I'll just leave these up because we can do it from here. Okay, I didn't show you on the calculator how to do a derivative, but I'll do that. But first I'll start out with the antiderivative. Okay, whether you use the calculator 84 in your phone, if you don't have one at home, or you're using a handheld, it'll still do the same thing. Say alpha y equals. And if I scroll over to this one right here, and I want to use number 4. You notice 3 is derivative. 4, it means integral right there. So we're going to say 4, and notice it pops up. Okay, we're going to do pi divided by 4, my lower limit, and then we're going to do pi divided by 2, my upper limit, and then 2 minus. Now, this is where it gets a little tricky with cosecant squared. Remember, it's 1 divided by sine. I'm going to close that parentheses, close that, and then square it. Okay, now I do have to arrow out and actually put the variable that we're using. All right, well, let's double check. That was our answer right here. So pi minus 2 divided by 2. Is it the same thing? And it is. All right. Again, you can do the same thing to see if you get 2 on that. Now, while I'm doing this, I'm going to show you derivative. Now, you do need to find and do the fundamental theorem of calculus by hand, because parts of the AP test are without a calculator. Just use this. So when you do homework tonight, you need to do everything by hand. Use this to check. All right, so just use this to check. Now, as far as the derivative, I'll show you that at this point. So what if I'm trying to find the derivative f prime of 4, and I say f of x equals x to the 4th plus 5x squared plus the cosine of x. All right, what I'm going to do is I hit that same button. I say alpha y equals, and I scroll over and I do the derivative, 3. Okay, I put my variable of x, and then I put the function in there. Now, this doesn't give you the derivative of it just with x and no point. You can only use this when it's given an actual value. Okay, so I'm finding it at 4. And there would be the derivative. You didn't actually have to sit here and actually do it out. Now again, the integral only works with definite integrals, where you have the upper and lower limits. So if it just gave you the integral, the indefinite, and you got to put plus c, you're going to have to do that all on your own.